So I have to go through this really, really quickly. I did this talk once and it took me 18 minutes and I only have 15, so I will skip a couple slides and we'll get there. Maybe we can answer one question. So this is about Graal. Graal's, I'm Chris, I work at Twitter. Send some tweets, be nice to JFocus. So Twitter is, you know what Twitter is, right? But it's a huge distributed system. We have many, many services. These are just a few of them. Probably the most important ones, the tweet service, user service, timeline, social graph, everything that has to do with users and stuff. And we have many instances of each service, like thousands of instances running on thousands of servers in multiple data centers. So it's a huge, business, basically. So we use a lot of open source stuff. We also give back to the community. So there's this one link where you can go to and browse all the stuff we've open sourced. And Graal's is also an open source project on GitHub, and you can download it. You can try it. It's a JIT compiler. It's written in Java. That's the difference to what we have today in OpenJDK. So it's a good fit for us. We can just take it, use it, try it out, see how it works. That's basically what this talks about. And we have our own JDK. So we build our own JDK. We have a bunch of add-ons, Twitter-specific command line, flags, and stuff like that. We are planning to open source it, and we're actually actively working on it, so it should happen pretty soon. So when I joined Twitter, this whole thing, what this talks about, that was basically my goal. I wanted to do that. So I ported Chap 243, which is a compiler interface. It has Java. It's a Java interface to the VM, so you can plug in an external compiler like Graal. You could potentially plug in any other one, but right now there's only one compiler that implements the interface. So we have something called Contrail, which is a JFR replacement. I'm not going to talk about that. And we have some CMS improvements, although we upstreamed basically all of it. I think there's only tiny little things left. Why? It's because C2 is very old and complex. I don't know if any one of you have ever looked at C2 source code or worked with it. It's highly complex. It takes you years to understand what's going on. While I was still working at Oracle, we had this issue. We hired people. It took them a couple of years to ramp up and be actually productive. And some of them even left before they got to the point where they could help us out and do or implement new things in C2 because they get frustrated. And I truly believe that C2 has reached its end of life a long time ago. In the last years, we've basically not done any major optimizations. Everything that's been done in C2 was somehow intrinsics related. So Intel's coming out with a new instruction set, and then we write new intrinsics for that, string index off, array copy and all that stuff. But we've not done any major, like we've not overhauled the inlining, we've not overhauled escape analysis and so on, because it's so complex and no one wants to touch it. So I think that Graal's learning curve is much shorter, just because of the fact it's not so old and it's much better designed. It's very modular. It has this is kind of an old screenshot, but at one point it had 83 Java projects in Eclipse, and they all there are no circular dependencies between these projects. And it's like what Mark said about modules, basically. And there are modules in there. There are projects in there. You can see it. Com, Oracle, Graal. They're called different now, but there are there are architecture independent packages and architecture dependent packages. So really, how it should be. I'm talking a little bit about bugs. The first one I skipped because I don't have time. The second one is a real bug that I found when I was running the tweet service for the first time at Twitter. The important part is the couple days, so it took a couple days to actually reproduce that bug. And after fiddling around and trying different things and running it for days and days, I found out that the Heapster agent that we were using is actually causing a problem. And Heapster is an agent that does heap profiling. So basically it profiles allocations. And what it does is it does bytecode instrumentation. And it turned out that because it instrumented bytecode, the double dot value off was also instrumented, but it was used in Graal itself, since Graal is Java, and that caused a problem. And so Doug, Tom and Doug discussed it, and he said, okay, we have to parse that differently. Snippets is basically what an intrinsic is. And so he fixed this. It's a rather large change. It touched 65 files, you can see it was actually a pretty invasive change. But now it works, which is great. The second bug was really annoying. So I was running the tweet service, and it started up, and you looked at the logs, and it was just throwing and throwing connection exceptions, and I didn't know why. And I had really no idea how to figure out where it's coming from. It could be any method that was compiled. By the way, I think the tweet service, once it's up, it compiled like 50,000 methods with Graal, and so I had to find out where it's coming from. And then, independently, someone mentioned to me that we were using Netty 3, and recently we've upgraded Netty 4, and so I thought, okay, maybe it's a good idea to run the Netty 4 test suite. And it turned out, Netty buffer, failure. Okay, I thought, well, it's better to fix that one. So we did, and this was a rather interesting one as well, because the snippet for reverse bytes had a bug, which is interesting because it's used everywhere. But it only failed in this one particular instance. It never failed anywhere else. Graal's like 5 years old. It never failed. But it failed here. So Tom fixed it. Small change, right? It was basically a copy-paste error kind of thing. So that was fixed, and after that, no more bugs. So I've never found another one. Since then, everything was running fine. So 7 minutes, great. So I'm going to show you a bunch of performance graphs. I've used the tweet service as an example here, and it's a Finagle thrift-based service. You can download Finagle from the open source page and play around with it if you want to. And so the way the testing was done is I had dedicated machines, so I did not have any other processes running on that machine. I had individual just one instance per machine, obviously, and all these instances got the exact same tweet requests. Same number, same tweet request, all of them. I was running with Graal VM 0.17. I think the latest is 0.19. So I could not upgrade. I didn't have time, but it doesn't really matter. All of these graphs are 24 hours. So it's a day of tweets requests. I picked this particular day, or these particular 24 hours actually, because it had high loads, and it had this like low plateau here where the tweet requests were pretty low. I don't know why. Doesn't really matter, but we will see some interesting artifacts because of that. One other thing I have to mention is there is no y-axis, and I'm sorry about that, but I'm not allowed to tell you, for example, how many tweet requests, what's our GC latency and stuff like that. I cannot say. Okay, so this is scavenge cycles. And it's a moving average of 60 minutes, so we can see what's happening. Blue is C2, orange is Graal, and we see that Graal is slightly better on the load. Right down here, where the load's low, it's about the same. But when the load's high, it's better, and it's about 1 to 2% less scavenge cycles. And the reason for that is that Graal has a different escape analysis implementation. C2 has, the regular escape analysis that's described in the paper, and Graal uses something called partial escape analysis. And so it can analyze away more object allocations, and so we have to do less scavenge cycles. But that has an interesting effect, because when you don't allocate, when you allocate less objects, and then you do a cycle, you have less garbage in your young generations. So there are more life objects in there when you have to do the cycle, and that means you have to copy more objects, and it takes longer to do that. So you can see, again, when the load's low, it doesn't really matter, it's about the same. But when the load's high, it can be up to 30% more cycle time, which is quite a bit, right? This is the old gen. What we can see here is we're doing roughly 4 cycles per day, which is not a lot. You see where the load was low, it's just creeping up a little bit. And what the interesting part is that Graal, the orange one, uses a little bit more of old gen. And it's between, here on the right, it's like only 10 megabytes, and over here it's like 60. The reason for that is Java, Graal is a Java application. It runs basically in the heap, and it has some state. So, and this is the 60 megabytes, it's just some Graal state. So you have to possibly increase your old gen size by a little bit to make up for it, right? But I just kept it that way. So very, very, very important for Twitter is obviously the tweet latencies, right? This is the time a tweet request takes. And it's a moving average of 10 minutes, and you see there are a few outliers here and there, but it looks like it's roughly the same. And the bottom graph is basically an integration over the top one, so you can actually really see the difference at the very right, and it's 1% more. So it's 1% worse in latencies, which I think is because of the higher scavenge times. And then we have P49s, which is even more important, right? And you see the graph is even more similar, it looks like, and then at the bottom you can see it's roughly 2.5% more. So that's unfortunate, but that's just the way it is. We possibly could, and I've tried it, but I haven't found the right ratio. You possibly could make your young gens a little smaller, and then maybe make up for it so that your scavenge cycle times are the same again. I'll play around with that, and we'll see if that works out. I like this graph a lot because the top one is uses CPU time, and the bottom one is system. And I could actually show the y-axis because it doesn't really matter. So system time is between 15 and 20%, let's say percent, that's roughly what it is, which is rather high, that's what Kirk said, and it's kind of true. At the top, you can see that Graal's better, especially when the load's low. And this possibly has 2 reasons. One is you have to allocate less memory, right? And so you do less cycles, so you don't use as much CPU time. And I think it also produces slightly tighter code. But it's like C2 and Graal produce roughly the same quality of code. And then this is my last, okay, no, wait. At the top, it's up to 4% better. So 4%, it's kind of nice to get that gain. And this is my last graph, and what it shows is tweets per the top one GC millisecond, and at the bottom per CPU millisecond. So higher is better here. And as you can see, because the cycle times were higher with Graal, so C2 is actually better at the top, but it doesn't really mean a lot. But the bottom one is very interesting, that especially when the load's low, we can send out much more tweets per CPU millisecond. And it's, at the top, it's 20% worse, so Graal's 20% worse than C2, and at the bottom, it's up to 8% better, which means if you have lots of instances running on lots of machines, that you can save some electricity and energy and cooling, and that means money. Okay, 15 minutes, unbelievable. So the summary is pretty short. What you've seen, we could basically run the tweet service on Graal. It's like the latency might be an issue. 2.5% could be a problem, P49s, but I think it would be possible. We're not doing it now. I've done it as an experiment on one instance. So one instance was running once in production, and for a couple days, and it worked totally fine. So that's it. Thank you.